Hello, class. Hi, I'm teacher Cecilia, and today we're going to learn about density. Hmm. You may be wondering, what is density? Like, what's the difference between a marker or a bottle of lotion? What's the density? Will this one sink and will this one float? Well, by the end of the sessions, you will be able to determine which object will sink, which object will float based on its density. Okay, let's go. So, as I said, what is density? Let's watch a short film about it. So, density. Hmm. Density equals mass over volume. Keep that in mind. We'll come back to that concept later. Hmm. Why is the apple floating and not sinking? Let's see. Look at the particles that the apple contains. Might it be that particles are the reason that things can sink or float? Now, let's look at the penny. Class, so why is the penny sinking but the apple is floating? Hmm. Again, particles. Ooh. So let's match the density to the value of the substance. As we can see here, each substance has a different density. By the end of the session, you will be able to solve for density and determine which objects will sink or float. Here you see it, the particles. So particles play a very heavy role in whether or not an object will sink or float. So now that you watched this video, let's continue with our learning. Does anyone have any questions? Okay, great. We'll keep going. So, I asked the question earlier, what is density? So please write this down. Density is a comparison of how much matter there is in a certain amount of space. So remember, when we watched the video, we talked about particles. Does anyone remember the difference between a solid, a liquid, or a gas? Oh, you do? Remember. Okay, so let's explain. When particles are in a solid state, remember they are tightly packed together. So this is how you get a solid, right? When these particles are in the liquid state, they have some freedom to move. They're not as orderly arranged. And then when they are in a gas state, they have complete freedom to move and bounce off the walls of the container. So we know that matter is anything that has mass and takes up space. So all items have some sort of mass and take up space. So mass, as we will learn, does play a huge role in density. Okay. All right. So we're talking about these particles again. So which square do you think is more dense? Would it be square one or is it square two? Hmm. Yes, it would be square two. Because if you think back to the video, we saw that the penny sunk to the bottom because it had more particles. More particles. Very good. Good job, class. Now, which one is more dense? Picture one or picture two? Yeah, very good. It was picture one. Good job. Again, we're looking at the particles because matter is made up of particles. Very good. Okay, so now let's apply this to a more real life example. So think about it. A brick is more dense than styrofoam because there is more mass packed into the same volume. So, more molecules or atoms in the same space. So, here are the particles of styrofoam, and here are the particles of a brick. They're the same size, but notice one has more particles packed tightly together. Now, here's the formula. So I will need you to write this down. Density equals mass over volume or mass divided by volume. Remember that this is the same thing as this, just written differently. Now, one very important point to note is that when you are solving for density or any mathematical equation, it is very important to remember your units. So, mass is measured in G, which is grams. Mhm. And then you have cubic centimeters when it's a regular shaped object. And we're going to talk about that in our next lesson, like the difference between regular and irregular. All right, so very good here. So when we're trying to get the volume, because we talked about volume here in the formula, we need to use the formula width times length times height. So what am I saying? You might say, teacher, what are you talking about here? So when we talk about a regular solid, this would be considered a regular solid. I must take the the width, width, and height, I'm sorry, in order to determine this, okay? And we will use a electronic version, digital version of we will use the electronic version of a triple beam balance in order to determine the mass. So this is how we get mass. So this you can think of like when you go to the grocery store and you're buying fruit and you want to see how much the fruit weigh. What you would do is you would use a scale. So this is, let's call it triple beam balance, and it's just a type of scale that we use in science to determine the mass of an object. Same way we go to the doctor and they want to determine our weight. So we'll solve for this. All right, so pretend we solved for it. All right. Now, we went over this formula. So now what we want to do is apply it to an actual scenario. Okay? So what I want you all to do is write down our shopping list because we're going to go shopping for formulas. All right. So the unknown variable. So what is it asking for? Um, and then you write down all of the known variables that are given to you. And then we'll determine what formula we're going to use. But before we go today, I want to show you all a quick little trick for manipulating formulas. So we do know that D equals mass over volume. Show you how this works in this neat little triangle. You see this line here? This represents the line that's in a triangle. So that means the M would go here. Where do you think the V goes? Yes, we will put the V here and then the D. The way that this triangle works is if D is the unknown and I cover this up, notice I'm left with an M over a V. If V is the unknown, that means that volume equals mass over density. Mhm. And then this line right here means to multiply. So we're going to multiply. So if I'm looking for mass, mass equals density times volume. So let's practice, class. All right.